This chapter is real numbers for standard 10 and this is part 11. We have been doing the problems related to Euclid's division lemma, applications of that. Now show that n squared minus 1 is divisible by 8 if n is an odd positive integer. So here it is divisible by 8. Generally when it is given divisible by 4, divisible by 3, etc., we take b is equal to those numbers. So here if we take b is equal to 8, then your remainders can be from 0 to 7, then it will become a long process. So instead, since it is n squared minus 1 is coming, you can take a factor of 8. So here we are going to take b equal to 4. So let a is equal to bq plus r. So b we will take it as 4 instead of 8. So a is equal to 4q plus r, where r is equal to 0, 1, 2 and 3. So it will become 4q, 4q plus 1, 4q plus 2 and 4q plus 3. So any odd positive integers, from this you know we have already earlier proved this 4q will be is a even positive integer, 4q plus 2 will be even and these two will be odd positive integers. So any odd positive integer is of the form 4q plus 1 or 4q plus 3 for some integer q. So now n is equal to, so the odd positive integer n, they have given n is a odd positive integer, so n is equal to 4q plus 1 or 4q plus 3. Now we will take case 1. So when n is equal to 4q plus 1, we have to find n squared minus 1. So n squared minus 1 is equal to 4q plus 1 the whole squared minus 1. So this is equal to 16q squared plus 2 into 4, 8q plus 1 plus 1 minus 1. So this is equal to 8 into 8q into, or even you can write 8 into 2q squared plus q. So 8 into this means it is divisible by 8. So now case 2. When n is equal to 4q plus 3. So n squared minus 1 is equal to 4q plus 3 the whole squared minus 1. So that is equal to 16q squared plus 24q plus 9 minus 1. So this is equal to 16q squared plus 24q plus 8. So we can take 8 as a common factor out, 2q squared plus 3q plus 1. So again you can write 8 into something, so it is divisible by, it is divisible by 8. Hence therefore you can write n squared minus 1 is divisible by 8. Prove that the square of any positive integer is of the form 4q or 4q plus 1 for some integer q. So here you can, since square of any positive integer since you have to take, so here we can take b is equal to 2 and then do. So positive integer, any positive integer is of the form 2m or 2m plus 1. You can also take as 4m, 4m plus 1, 4m plus 2, 4m plus 3 and then do for all the, you have to square it and see. Or here you can find it with 2m also. So we will do it with 2m plus 1. So let a is equal to 2m. So we will find a squared, square is equal to a squared is equal to 4m squared. So this is equal to 4q, where q is equal to m squared. Now when a is equal to when a is equal to 2m plus 1, a squared is equal to 2m plus 1 the whole squared is equal to 4m squared plus 2 into 2 4m plus 1. So this you can write it as 4 into m squared plus m plus 1. So this is of the format 4q plus 1, where q is equal to m squared plus m. Now we will do the same problem with let any positive integer is of the form when we are taking b is equal to when we are taking b is equal to 4. Here we took b is equal to 2. So here we are taking 4. So a is equal to, you will get 4m plus 1, 4m plus 2 and 4m plus 3. Write down all the steps when you write for your exam. Now case 1, when a is equal to 4m, a squared will become 16m squared, that is equal to 4 into 4m squared. So this is equal to 4q, where q is equal to 4m squared. Now when a is equal to 4m plus 1, a squared will become 4m plus 1 the whole squared. So this is equal to, I can write this as 4 into 4m squared plus 2m plus 1. So this is of the format 4q plus 1, where q is equal to 4m squared plus 2m. So now when a is equal to 4m plus 2, so a squared is equal to the same procedure only. So this again I can write this as, this is equal to 4 into 4m squared plus 4m plus 1. So this is also the format 4q, where q is equal to 4m squared plus 4m plus 1. When a is equal to 4m plus 3, a squared is equal to 24m plus 9. So this I can write it as 16m squared, or I will take 4 into 4m squared plus 6m plus 2, 9 I will write it as 8 plus 1 plus 1. So this is of the form 4q plus 1, where q is equal to 4m squared plus 6m plus 2. So here you were able to prove with when you take BS 2 and BS 4. Hope you understood this procedures. So I'll meet you all with some more problems in my next video. If you find it useful, please subscribe, share and give your comments. Bye for now.